Today, anyway, we have studied this chapter columns and struts in the basic of centrometers. In the centrometers, you have studied this particular chapter, and you have also come across the various Rankins equation to find out the value of crippling load. It's a diagram. Before going for this particular columns and struts, first of all, we should know what is meant by a column. Already we have studied or we have come across that particular term column. How we are going to define this particular column? It is nothing but a vertical member which take up only the compressive load. Okay, you make this particular column to you are going to apply only the compressive force. Okay, it is nothing but a vertical member which is subjected to compressive forces, which is subject to a compressive load. Isn't it? That in general we call it as a column. Then how we are going to define that particular strut? Strut is also a member which take up the compressive force, but it may be either vertical or it may be either inclined. Column is one which is purely vertical, which take up a compressive force that we call as a column, which is nothing but a slender member. What do you mean by slender? The length and the width are larger when compared to the cross-sectional dimension. That we call it as a slender member. A vertical slender member which is subjected to purely a compressive force, that in general we call it as a column. And how we are going to differentiate with the strut? Strut is also a compression member, but it may be inclined or it may be vertical. That short compression member, in general, we are going to call it as a strut. Where you come across this particular strut? For example, in the case of trusses. In the case of this particular truss, this member is a strut which take up that particular compressive force. That in general, we are going to call it as a strut. Now, how we are going to differentiate this particular column into a long as well as a short column? How we are going to differentiate? On what basis we are going to differentiate this particular column into a long as well as a short column? That mainly depends upon L by D ratio. Okay, that differentiation of this column. Okay, whether it is a long column or a short column mainly depends upon what we call it as the L by D ratio. What is L? L is nothing but the length of the particular member. The length of the particular member or height of the member, and D, it is the minimum lateral dimension. It is not the diameter. It is the minimum lateral dimension or the thickness. That we call it as D. L is the length of the member. D is the minimum dimension, minimum lateral dimension. It is not the diameter. Minimum lateral dimension that we are going to take up. If this ratio is greater than 12, if this ratio is greater than 12, then you are going to call that particular column as a long one. If that particular ratio is less than 12, then you are going to call it as a short column. Okay, this is the main basis upon which we are going to differentiate between a long column as well as a short column, mainly depending upon this L by D ratio. If the value of L by D ratio is greater than 12, you call it as a long column. If that ratio is less than 12, then you are going to call it as a short column. Anything in between this, in general, we call it as a intermediate columns. Is right. That already we have come across. And for this particular column, now the basic example for this long column is, see, if you take a long column, okay, you are going to apply, say this is the particular column, and you are going to apply the load at the ends. Now the length of the column is larger. If you apply a minimum load, it starts to bend. If you apply a minimum load, vertical compressive load, it just starts to bend. The load required to cause this particular member in the lateral direction or buckling, we call it as the crippling load. What we are going to define the crippling load? Crippling load is nothing but the minimum load at which the column just starts to buckle. The column just starts to buckle. Okay, ಇದು ನೋಡಿ ಇದು ಲಾಂಗ್ ಕಾಲಮ್ ಅಂತಂದ್ರೆ ಇದು ಬೆಂಡ್ ಆಗಲಿಕ್ಕೆ ಸ್ವಲ್ಪ ಲೋಡ್ ಅಪ್ಲೈ ಮಾಡ್ತಿದ್ದಕ್ಕೆ just starts to bend. And that particular load at which the column just starts to buckle, we call it as crippling load. ಈಗ ನೋಡಿ ಲೆಂತ್ ಆಫ್ ದಿ ಮೆಂಬರ್ ಜಾಸ್ತಿ ಇದ್ದಾಗ ಲೋಡ್ ಕಡಿಮೆ ಬೇಕು ಫಾರ್ ಇಟ್ ಟು ಬೆಂಡ್. ಒಂದು ಸಣ್ಣ ಸ್ಕೇಲ್ ಕೊಡಿ. Now you can see that once again the same member, it is a vertical member but it is short. Say ಇದಕ್ಕೆ ಲೋಡ್ ಇದು ಬೆಂಡ್ ಆಗಲಿಕ್ಕೆ you require more load compared to this. ಇದು ಉದ್ದಾದಂಗೆ ಏನಂದ್ರೆ ಸ್ವಲ್ಪ ಲೋಡ್ ಅಪ್ಲೈ ಮಾಡಿದ ತಕ್ಷಣ ಇದು ಬೆಂಡ್ ಆಗುತ್ತೆ. ಹೌದಾ? ದ ಲೋಡ್ ರಿಕ್ವೈರ್ಡ್ ಟು ಮೇಕ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಾಲಮ್ ಟು ಬೆಂಡ್ ಈಸ್ ವೆರಿ ಲೆಸ್. ಇದು ವೆರಿ ಲಾಂಗ್ ಕಾಲಮ್ ಅಂತ ಹೇಳ್ತೀವಿ. If we come for this is the intermediate to bend is little bit more than this particular one. Correct? ಇದಕ್ಕೆ ಈ ಕ್ಲಿಪ್ಪಿಂಗ್ ಲೋಡ್ it will be more for this particular one. If it is a short column, ಇದನ್ನ ಬೆಂಡ್ ಮಾಡಲಿಕ್ಕೆ much more amount of the load is required. ಇದನ್ನ ಬೆಂಡ್ ಮಾಡಲಿಕ್ಕೆ much more amount of the load is required. Therefore, this particular member, long columns, fails mainly due to a compressive load as well as a bending load. Bending means buckling. This particular column fails or it is subjected to both the compressive force. This load of the compressive force is there. Due to this particular bending, this is also subject to bending stress. Therefore, this long column will be subjected to a compressive force as well as the bending stresses. Bending compressive stresses in the lateral direction. How they do? Yes. If it is purely a short column, ಇದು ಬೆಂಡ್ ಆಗಲಿಕ್ಕೆ ತುಂಬ ಕಡಿಮೆ ಇರುತ್ತೆ. ಇಟ್ ಫೇಸ್ ಮೇನ್ಲಿ ಡ್ಯೂ ಟು ಕಾಂಪ್ರೆಸಿವ್ ಫೋರ್ಸ್. ಬೆಂಡಿಂಗ್ ಸ್ಟ್ರೆಸಸ್ ಬೆಂಡ್ ಆಗೋದೇ ಕಡಿಮೆ ಇದು. ಬೆಂಡಿಂಗ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಒನ್ ಶಾರ್ಟ್ ಕಾಲಮ್ ಫೇಸ್ ಮೇನ್ಲಿ ಡ್ಯೂ ಟು ದಿ ಕಾಂಪ್ರೆಸಿವ್ ಸ್ಟ್ರೆಸ್ ಆರ್ ವಾಟ್ ಕಾಲ್ಡ್ ಆಸ್ ದ ಡೈರೆಕ್ಟ್ ಸ್ಟ್ರೆಸ್ ಬಟ್ ನಾಟ್ ಡ್ಯೂ ಟು ದ ಬೆಂಡಿಂಗ್ ಸ್ಟ್ರೆಸ್. ಓಕೆ, ಇದು ಕಾಂಪ್ರೆಸಿವ್ ಲೋಡ್ ಅಪ್ಲೈ ಮಾಡೇ ಫೇಲ್ ಆಗುತ್ತೆ. ಯು ಸ್ಟಡಿಡ್ ಇನ್ ಕಾಂಪ್ರೆಷನ್ ಟೆಸ್ಟಿಂಗ್ ಮಿಷಿನ್ UKM ಅಲ್ಲಿ ಮೈಲ್ಡ್ ಸ್ಟ್ರೆಸ್ ಸ್ಪೆಸಿಮೆನ್ ಚೆಕ್ ಮಾಡಿದ್ರಿ. ಶಾರ್ಟ್ ಸ್ಪೆಸಿಮೆನ್ it fails mainly due to compressive force. It fails due to the compressive stress only. If it is an intermediate column, it is subject to both compressive as well as the bending stress. Okay, if the length of the column is too large, tumba height ittandre, it fails mainly due to bending stress. But compressive stress will be lesser. Tumba length of the column ಜಾಸ್ತಿ ಇತ್ತಂದ್ರೆ the failure is mainly due to the buckling load. If it is in between, okay, long and the short column, that is intermediate column, the failure will be due to the compressive load as well as the buckling load or the bending stresses. And if it is a short member, if it is a very short member, this fails mainly due to the direct stress. Okay, anyway, we have differentiated into a long column, short column, a long column with the aperture ratio greater than 12, and if it is less than 12, we call it as a short column. We know the basic definition of, because these columns are subject to compressive force. Anyway, due to the application of this particular load, it undergoes bending. It takes up the compressive stress as well as the bending stress. How we are going to define this clipping load? The minimum load at which that particular column starts to bend, that in general we call it as the crippling load. With this is the review. Anyway, various end conditions will be given to this particular column. Various fixity conditions will be given to that particular column. There are 4 fixity conditions which we are going to provide in actual practice. 4 fixity conditions we are going to provide in actual practice. The first and the foremost one is what? When both ends are hinged. Okay, and n is the length of this particular column. Now, both the ends of this particular column is hinged. If this is the case, the minimum load at which the column just starts to buckle, we call it as the crippling load. So, if you are loading at the bend agutto, that in general we call it as a crippling load. Now, this is the nature of bending. This is the nature of bending of that particular column when both ends are hinged. If both ends are hinged. Okay, is it clear? Now, PCR is nothing but the minimum compressive load at which this particular column just starts to bend. That minimum load in general we call it as a crippling load. Now, here the first condition is both ends are hinged. Both ends are hinged. This is the nature of buckling. Then, with one end hinged and the other end is fixed. If this particular column at the 2 ends, one end is hinged, this is hinged, and the other one is fixed. Is it like that? Then how does that particular one buckles? The minimum load at which the column just to start to buckle is in general we call it as the crippling load. Then what is the nature of bending? This is the nature of bending of that particular crippling load, because at fixity the slope will be equal to 0. This we know. This is the nature of bending of that particular column. Okay, when one end is fixed and the other end is hinged. Okay, and this is one end is one end hinged, and other fixed, The third one is when both the ends of that particular column are fixed. ಎರಡು fixity ಇದ್ದಾಗ the slope at the two ends will be equal to 0. This is the nature of bending. This is the nature of bending. That is, when both ends are fixed. When both ends are fixed. This is the nature of bending. And the last one is, one end is fixed and the other end is free. One end fixed and other free. Okay, this is the gripping node PCR. This is PCR. This is how it bends. This is how it bends. That particular column bends, and the minimum load at which that particular column just starts to buckle, we call it as the gripping load. Now, these are the four ways by which that particular column undergoes bending. Okay. Now, when you observe this nature of bending, see, now these two end points are hinged. What's the moment carried by that particular hinges? Always it will be equal to 0. It does not carry any moment. Is that right? Okay. Now, these two ends are hinged. L corresponds to the actual length. Okay. When you come for this particular one, that is one end is hinged and another end is fixed, you can observe that this particular column up to here it will be in a case hogging, and thereafter it will be in the it is a portion of sagging. Hoga, ilinda hogging is there, and ilinda sagging is there. This length, in general, we call it as the effective length. That length, in general, we call it as the effective length. Ilinda hogging is there, ilinda sagging is there. That particular point where it changes from hogging to sagging, in general, that length we call it as an effective length. Effective length, this itself will be equal to the effective length when both ends are hinged. 0 is there. Bending moment is 0. Hogging in the sagging gate will be equal to 0. It will be 0 itself. Therefore, the length itself will be equal to the effective length when ends are hinged. When one end is fixed and the other end is hinged, L is the actual length and LE is the effective length. Okay. Then what is the magnitude of that particular effective length? This will be equal to L by root 2. This length, if you are going to measure it, this will be equal to actual length divided by root 2. If the measurement this length will be there. Then when both ends are fixed, this is the point where bending moment is 0 or it changes from hogging to sagging or so. And this length is nothing but equal to the effective length when both ends are fixed. L corresponds to the actual length of the column. If you measure this particular distance, this length, effective length will be equal to L by 2. It will be equal to L by 2. And here, this effective length LE will be this particular portion will be equal to 2M. That will be equal to 2M. Okay. Now, what is the generalized expression? Okay, we have studied when both ends are hinged. When both ends are hinged, the gripping load is given by the formula. What is the formula for the gripping load? That is, gripping load is given by PCR is equal to pi square EI divided by L square. Like, this is the standard one. When both ends are hinged, the gripping load or the minimum load at which the column just starts to buckle is given by the expression pi square EI by L square. Is that right? Now, always we have to write down the expression for the gripping load in terms of effective length. In terms of effective length. Then what do you mean by this effective length? Here I have shown that LE is the effective length. Here LE is the effective length. How much? L by 2? LE is the effective length which is equal to L by 2 and LE is equal to 2L. Then what is this effective length? Effective length of the column is nothing but that particular length for a column which is made up of the same material, is a right, with the same hinge conditions, same material with hinge conditions. If you take up this particular length, okay, the load whatever going to apply, we are going to get it for the column. If length now same load same material E length of the member effective length of the if you measure that particular critical load in the actual column, that remains the same. That length in general, okay, we call it as the effective length. Effective length, it is nothing but that particular length. Now assume which is having both ends hinge condition, which is made up of the same material, with the hinge length. What's the bending moment here? 0. What's the bending moment here? Which is equal to 0. ಈ length ತಗೊಂಡು ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ we are going to get the actual loading. How we shall see? Suppose in general PCR is given by pi square EI by L effective square. Always we are going to write it in terms of effective length. When both ends are hinged, what is effective length? Effective length is nothing but equal to actual length. Correct? For the first condition, effective length is nothing but equal to actual length. Then what's the expression you are going to get? PCR is equal to pi square EI by L square. When both ends are hinged, if you substitute L effective is nothing but equal to the actual length, because bending moment here it is 0, here it is 0, then we are going to get the crippling load, which is given by pi square EI by L square. If you come across for this particular one, okay, what is the generalized expression? Pi square EI by L effective square. When one end is fixed and other end is hinged, then LE is equal to L by root 2. Substitute LE is equal to L by root 2. We are going to get 2 pi square EI by L square is the PCR for the actual loading. Actual loading is derive now. We have derived for the 4 conditions. Always we write in terms of the effective length. E effective length ನೋಡಿ L is equal to L by 2. E length ತಗೊಂಡ್ರೆ where the bending moment ಇಲ್ಲೂ 0 ಇದೆ ಇಲ್ಲೂ 0 ಇದೆ. E length ತಗೊಂಡ್ರೆ you are going to get the actual loading for that particular column, which is nothing but you are going to get 2 pi square EI by L square. ಇದನ್ನ ಡಿರೈವ್ ಮಾಡಿದ್ದೀವಿ ನಾವು actual loading ಗೆ. E length substitute ಮಾಡಿದ್ರೆ you are going to get the actual loading. If you go for this, okay, what's the basic expression? PCR is nothing but equal to pi square EI by L effective square. What's the effective length? ಇಲ್ಲಿ bending moment 0, ಇಲ್ಲಿ bending moment 0. Okay, E length substitute ಮಾಡಿದ್ರೆ what is LE? LE is nothing but equal to L by 2. Bending moment here it is 0 and bending moment here also it is equal to 0. If you substitute LE is equal to L by 2, you are going to get 4 pi square EI by L square. This is the PCR for the actual column. Correct? ಇದನ್ನೆಲ್ಲ ಡಿರೈವ್ ಮಾಡಿದ್ದೀವಿ. And the last one is what the basic expression? PCR is equal to pi square EI by L effective square. Here L effective is nothing but equal to 2L. Substitute ಮಾಡಿದ್ರೆ the actual crippling load is given by pi square EI by 4L square. This is that already we had derived. Now we have come across this particular one. ಏನಪ್ಪ effective ಅಂತಂದ್ರೆ that particular length where bending moment is 0. ಇಲ್ಲಿ 0 ಇದೆ. Illu bending moment changes its sign. Illu 0 ಇದೆ. If you take this as the effective length, okay, and substitute and take that particular length for the imaginary D, which is made up of the same material. ಅಲ್ಲಿ substitute ಮಾಡಿದ್ರೆ you are going to get the expression for the actual column ಗೆ ನಮಗೆ ಬರುತ್ತೆ. Isn't it? That in general we have this is when both ends are we come across pi square EI by square. When one end is fixed and other end is hinged, we are going to get 2 pi square EI by square is the crippling load. When both ends are fixed, we have to write 4 pi square EI by L square. And when end is fixed and other end is fixed, it is given by pi square EI by L square for the actual column. ಇವನ್ನೆಲ್ಲ ನಾವು ಓದಿದ್ವಿ. ಕರೆಕ್ಟಾ? Effective length ಅಂದ್ರೆ it is an imaginary length. Imaginary length with both ends hinged. ಎಲ್ಲಿಂದ ಎಲ್ಲಿ ಮಾಡಿದ್ವಿ? ಇಲ್ಲಿ bending moment changes ಇಂದ ಇದು ಹಿಂಜ್ ಆಯಿತು, ಇದು ಹಿಂಜ್ ಆಯಿತು. That length we are going to take it, and that length in general we call it as the effective length. ಅಷ್ಟು ವ್ಯಾಲ್ಯೂ ಆಫ್ effective length substitute ಮಾಡಿದ್ರೆ we are going to get the actual crippling load for the actual column. L is equal to L ಮಾಡಿದ್ರೆ ಬಂತು. L is equal to E length substitute ಮಾಡಿದ್ರೆ we are going to get the actual load carrying capacity of that particular column when one end is fixed and other end is hinged. ಅಂದ್ರೆ ಏನು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬಂತು? ಸೇಮ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರುತ್ತೆ. Right? Is it clear? Okay. Now with this as the basics, we write.